Alright guys, so a lab that we would have done if we were in class is the laboratory technique of determining the specific heat capacity of a metal. And remember, as I'd said in class, the specific heat of a substance is a great way of identifying its identity, just like we do with density, because every substance has a unique specific heat. And so one technique we can use is a laboratory technique that's called calorimetry. So in calorimetry, we actually take a super high-tech styrofoam cup and we fill that cup with water. And we can determine the initial temperature of the water. So I'm going to give you just a practice example to show you this technique. So let's say, for example, the water starts out at a temperature of 25.32 degrees Celsius. Okay, and the mass of that water, let's say, for example, I'm going to use, 90 grams of water. Okay, and so what I do in order to determine the specific heat of a piece of metal, say I just have a random piece of metal here, is I'm actually going to put it first into boiling water. So it's going to go into boiling water, and it's going to get really, really, really hot. Well, what temperature would it reach? It's going to reach the temperature of that boiling water, and boiling water boils at 100 degrees Celsius. So the initial temperature of my metal, as soon as I take it out of that boiling water, is going to be 100 degrees Celsius. Now I'm going to take that piece of metal, and I'm going to add it to my water, okay? And so now I've taken that metal, I've added it to the water, okay? And so I'm going to measure the temperature of this water using a thermometer until it reaches a final temperature, because it's going to increase in temperature and eventually it's going to stop. And let's say that final temperature, for example, is 27.18 degrees Celsius. Okay, so that's going to be the final temperature of the water. And one other piece of information that I forgot to tell you was, let's say, for example, my metal has a mass of 25.0 grams. Now, the whole crux of this laboratory technique of calorimetry, which is what we are using, is the assumption that all of the heat that the metal releases, so the metal is going to release heat, and we're going to represent that with a negative Q. We're going to assume it loses that heat. That's going to equal the heat that the water absorbs. Okay? So this metal was heated to 100 degrees Celsius. It was put into water, and all of the heat that it released goes to the water, and the water absorbs it. So the heat that the metal releases equals the heat that the metal absorbs. We're going to make that assumption. We're in a styrofoam cup. We're going to assume we lost no heat at all. Okay? So now what I know is that the negative, so remember we're using the formula Q equals mc delta T, the negative mass of my metal times the specific heat of my metal times the change in temperature of my metal, keep in mind that is my Q of my metal, is going to be equal to mc delta T of water. So the mass of my water times my specific heat of water times my change in temperature of my water. So let's plug in all of these values I know. So here I know the mass of my metal is 25 grams. I don't know my specific heat. That's the whole point of this lab. My change in temperature is going to be, well, it started at 100 and it changed to 27.18. So TF, 27.18 minus 100 is going to be negative 72.82 degrees Celsius. Now let's figure out everything for my water here. The mass of my water is 90 grams. I know the specific heat of water is 4.18. And then the change in temperature for my water, well, it ended at 27.18. It started at 25.32. And so the change in temperature of my water is going to be 1.86 degrees Celsius. Okay, so with all of this information, I now know my specific heat of my metal. I just need to multiply these guys and divide by negative 25 and by negative 72.8. And so the specific heat that I get of my metal is 0.36 0.385 joules per gram degree Celsius. So to recap, in calorimetry, you're going to take a hot piece of metal that's at 100 degrees because it's going to be from boiling water, and you're going to transfer it into a calorimeter. This is a calorimeter. It's just a styrofoam cup with water in it. That metal is going to release heat, and all of that heat is going to be absorbed by water. And what that assumption, this is the crux, this is the formula that is the crux of your calorimetry lab. What that allows me to do is say, all right, I know the mass of my metal. I know the change in temperature of my metal because it went from 100 to 27.18. I know the mass of my water. I know the specific heat of my water because that's given. And I know the change in temperature of my water. It went from 25.32 to 27.18. With all of that information, I now can calculate the specific heat of my metal. And then I can go and say, hey, all right, if I know the specific heat of my metal, now let's look at all of the different possibilities for what it could be and match it up to see if that matches up with the specific heat that I'm interested in. And that's it.